Прием, прием. Ю-ю-ю. Алло. Ты думаешь, так много людей, так мало людей. Надо держать тогда. Я опять держать и что? Алло. Это используется как что это? Наоборот. Слушай, нет, наоборот. Правильно. Вы не выбрали? tev jau. Надо кто-то выпустить. Rīgas, Ziet, drīz sāks kaut ko rādīt, varbūt. Unity man strādā šobrīd, TV arī strādā. Jā, 1, 2, 3, 4, 5, 7, 8, 9, 10. Tālāk neprotu skaitīt. Kā jums tur iet, vai jūs mani visi dzirdat? 1, 1, 1, 1, 1. Нет никаких recording devices. Būs. Ну, да, но тогда будет уже... Я буст включил еще побольше. Может, Hello. Левел поднялся. Hello. Окей. Nu, manis pēc jā. Es nezinu, kā tur ar pārējiem. Лучше или как там? Tev arī labi bija ar to mikrofonu, jā? Okay. Kāds atvēršanas runa te? Okay, I can start. You have two options. My very bad language English, or little bit better Latvian language. English or I can Latvian speak. English probably, yes, but I have very bad languages. Okay. Okay. Today I try to show how to make day-night title is in Unity with very easy configuration. And first, of course, we open new Unity scene. Here is nothing now, just my camera and direction light. I just set up one terrain for little better showing. Yes, it's just okay, and just put some little some buildings. It's just for demonstration. Okay. I think it's enough for our needs. Here is some buildings, some shadows from buildings, and no, of course we need change day and night. Day is light, night is dark. for this, simplest way is just change intensity of this direction light. We see here is intensity, and if you change this intensity, you can change some lights. With this, we starting. Just create new C# script. Day nights. Okay, and we maybe it's opening. Yes. Open. Open. A very big script because yes, we need. Oh. Too late. Maybe after presentation I can more tell more about this. But no. At starting, we of course I just set up a little bit different things we need. We need just control of day holes. Yes, just for showing. It's not something. It's not special. Just for showing horse. Here, yeah, I just create this and UI text and now I put this text in some yes tech. This is 24 hours. Oh, maybe little more. 40. Okay. It's, as I say, it's only for what we see. Okay. And here in our script we make one publish float variable, calling it whole. It is our whole presentation of the day. And one more public float whole time. It's for how long is one whole. It's for seeing this you can, it's not about day nights, it's just for showing how we can change night this day. Then we whole time time. Okay. Maybe little is, but I think I just ducks. And here we our presentation. Public. Text. text. And for using text variable, we need using I. So save, and here we this script attached to our light. Just drag it here, and we see this our two variables, hold and hold time, and we just drag this text component for showing our hold. This presentation is it's not only about day night, but a little bit about Unity editor using. When you set this hold, we just showing this hold text text. It's hold. No. Hold. Okay. 0. So okay. For this setup, we if I run this project, we can see how run nothing. Yes, because I have okay. Yes, of course. No. Yes. Example 2. And here, because we yes. Okay. Just counting our code, and now I just show how it's possible change these values without always running this game. Just using I don't know how it's calling. Yes, I know how it's calling this method, but I don't know how it's calling this construction for no hide. Why hide? Execute in edit mode. Yes. Okay. Then when we using this command, maybe all changes we can see in our editor. Just compiling, and nothing. Why nothing? Okay. Execute and edit more. Yes, of course. Then we just change this whole manually in editor, but we using one editor command calling range. Range we can put from 0 to 24, and then we this not need but now, and here when you compiling, yes, we see one nice slider, yes, and we can change this our whole, yes. Okay, the setup I think is done. Yes. Then first I don't change intensity of light, but I change if we see just this beautiful shadows, and when we change this rotation, yes, we have just imitation of the day. I know this is wrong way, right way. I tell you a little bit later, but now we just find our whole of the day. We just find in percent value. Yes, then prots it's 20. It's whole 24. It's because we don't need change our angle in 20 or 24. We change from 360 to 0, or then we change this angle, because just little we need read existing. This, and we change y, this y angle to 360 multiple prots, and of course we need set up this angle back. And okay, as we see, our rotation is working, and day is changing our angle. Yes. Okay, but of course it's not a day night. It's everything is bright, and we need change this intensity of light because we using in editor mode we can't set up local or private variable for light. I need calling get component every time in update. Yes, then we need lights intensity is, and here is part one. If I set just prots, it's from 0 to 1. Of course, day night's not changing from 0 to 1. It's in night it's darker, in morning it's little bit brighter, and in day it's bright and more and more. For that, you can of course write if prots is, or maybe hor is it's less than, if hor is less approximately 6 or 5, yes, then you change bright this intensity one step or another. But using one property in Unity, it's calling animation curve. Yes, curve. Okay, this is public animation. Oh, here is curve and the lights. What is it? Is it nice component? And when you after compiling, you here see this property daylights, and you can change its this graphic how it change from 1 to 0 1 sorry 0 to 1. Yes, it's in percent. Yes, 1 is 100%, 0 is 0, and you can make your this Bezier line what you need, and you can set up this this lights from here. You can using many modes for this changing. Okay, it's of course it's not I just set up some line, and you can after that okay, I just that, and after that you can using these properties in that mode. Yes, we calling this variable daylights and evaluate and outputs, and this function return value of that point in percentile okay, you understand. From this line, yes, and you can see, okay, first is dark, lighter, light, bright. No, yes, it's not so so very nice. Okay, yes, okay, but as you see, it's not very dark in night. Yes, day it's okay, but night it's not night. It's just, I don't know. Yes, for that we need change our light parameter for our scene, and here is I open Windows and lighting. First, we need to change ambient source from skybox to color. Maybe you can use gradient, but at now we using just color. And if you change this color, yes, you can see it's very dark. If you can put this color to black, it's dark. It's not, of course, so dark what you need, but if you change this skybox material, yes, it's by default, it's default skybox. You can set just black skybox, yes, and all is very dark, yes, and then you change this light, you can see how change it this color, yes, but of course we need change this color from our script. For that we using another editor, nice property calling property public uh, gradient, yes, gradient, gradient, yes, gradient, and we here set day color. Okay, and now we see another property. Here is just gradient where you can change this color. We can set beginning color and end color, set new color, at morning maybe yellow, at evening red, there is red, day it's white. Okay, it's maybe just for little improvements. Oh, our day night, it's at night it's very dark. It's at morning it's little bit yellow, day is white, and red and black. Okay, for using this it's very simple. If we get uh, render set render settings, yes, it's render settings, and we can change ambient color color, don't see, maybe not ambient color, ambient light. Okay, ambient light, it's okay, for day color gradient component evaluate, and for props. Here is our just changing this color, getting from this component. It's compiling, and no, yes, 0, it's very dark, it's yellow, it's 6 o'clock, day 20, yes, our sun is rotating, evening red, and sun is down. Okay, and that it's almost about all changes, but as I said, it's a little cheating with rotation, because rotation it's not really right. In here we can see it when I set this shader back to default skybox and setting light or this directional light, and we have sun. Where is our sun? Oh, here is sun. Yes, and now when we rotating the sun, this sun goes down, sun goes up, rotate around your world. But when I cheating, I just around about Y axis, yes, and then you don't get nothing. Ah, yes. But for this change, it's just we need using uh, just mat functions for rotation and setting transform. It's rotation. It's quarter. Yes, we rotate about vector 3 right. Yes, and here using this insert this degree, and here is multiple prods, and here I need just minus 90 because sun is I don't know why. I know, but I don't know how it's say. No. Thank you for your comments. Okay, this it's I think maybe. Okay, where is our sun? Ah, and okay, he's going to the wrong direction. Ah, yes, we can just and yes. Okay, sun is going down, and we have a little darker above. Ow. Oh. Here you can see what it's rotated around this. Okay, that's all. Yes, if you have just a moment, because in runtime we have just some problems. Yes. Yes, but I if I just checking if I running in editor mode. is editor. Just no, I don't know in editor. Yes, it's this, and I need check it one check because whole is greater than 24, then we change back to the 0. Whole bigger, and it's 24, and then we set 0, else I think that if you see some problem, just tell me. Okay, okay, working, and of course, camera. We set up this camera just like that. Yes. Yes. Okay. Some problems, problems, not the problems. It's whole time to. Okay. Uh, player, playing, why player? Control, yes. Okay, compiling and running. Oh, yes. Yes. Okay. I just showing one features for this building. It's first question in yes, we can switch this building in the lights, and then we need I showing just one. You need maybe some array of these buildings, but I just show on one. Then public constructor building and set here building. But it's wrong. Why building? No. It's not construction. Constructor building. I don't know. Lights on. Here is maybe whole whole less than 6, 7. Okay. Or or yes, I know, but I just for quick solution, for it's bigger than 20. Okay. And something is okay. Wait. I just not attaching this building. As you see, it's the smallest building. It's showing only. Oh. Okay. That's it. That's it. This. Oh, it's like nice build. So first, I
Nezinu, kaut kā jau es runāju. Es nelaiku tik labi spēlēt. Labi. Vienkārši nav arī man labāks spēlēt. Tas ir pārāk 5 minūtēm traumas.
Ooh, there were batteries left.
Tāpēc neskatieties tie nosaukumā. Prikopēt.
Here's a little something for you. That's for wearing pink.
Missed!
Look, compacts from heaven. Hup. Hup.
Just you wait.
You laddered my tights. Look, compacts from heaven. He went all limp.
Special delivery. Watch this. Traitor.
Ooh, there were batteries left. Take this.
Ow! I'll get you. Special delivery. Watch this.
I'll come back, you know. Look, compacts from heaven.
I'll get you. Fire! Ow! Ow! Traitor!
Look, compacts from heaven. Special delivery.
Oof. Just you wait. Watch this.
You laddered my tights. Ooh, there were batteries left. A token of just how much I like you. Here she comes. Silly bitch.
Special delivery. Watch this. Traitor.
Look, compacts from heaven.
Take cover! Oi, nutter! Fire!
You laddered my tights. Ooh, there were batteries left. Here's a little something for you.
Oof! Just you wait. Special Special delivery. Watch this.
Oh,
Revenge.
ooh, there were batteries left. A token of just how much I like you.
Ow! 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 Ow!
That's for smudging my mascara.
Oh dear. Watch this.
I'll come back, you know. Oh, she went all limp. Ooh, there were batteries left. Hup. Hup.
You'll regret that. Bye-bye.
Ooh. Silly bitch.
Incoming! Whoops.
Ooh, there were batteries left. Hairspray.
Missed. Watch this.
I felt a breeze. Ooh, there were batteries left. More shopping.
Fire! Traitor!
Ooh, there were batteries left. Oh dear.
Fire!
You'll get a slap. Ooh, there were batteries left. Hup.
Ow!
That's for smudging my mascara.
Missed! Fire! Revenge!
Oh, she went all limp. Ooh, there were batteries left. More shopping. token of just how much I like you. Hup!
You'll regret that. Revenge! Revenge!
Oh, there were batteries left. Take this.
Nej, han har hållit med.
That's for smudging my mascara.
Bra. Business med
Fire!
Nej, försvinner.
Oh dear.
Det är någon.
We win. We're all queens now.
Du vill ska ta reda på mig, Okej, väl. Oh man.
Tas nav mans dators. Es neko nezinu, tas nav mans dators. Neko nezinu, es neko neesmu teicis. Ko man sāk? Vai? Jā, tipa. Tā izstāv. When you go to somewhere, no, your place. Laikam jau. Man runāt angliski? Yep. Okay, I'll speak English then. Okay, so. Oh yeah. Okay, so. Hi, I'm Naudis. Most of you probably know my name anyway. But yeah, so I'm gonna talk about like procedural animations in 2D games. And I'm gonna tell you a story of how I used to work on a program called GameMaker, and at least back then you didn't really have any like a lot of animation tools in GameMaker. You could make frame animations, you could do some pixel art, but I was never really good at that. So what I did instead was I made all of my animations in code. So I made this game a couple of years ago where you could okay, where you could crash the game. Okay, never mind. I'm gonna do something else instead. This This is like an old version or something. Doesn't even work anymore. What? Okay, it doesn't work. Whatever. Anyway, the point is, it had like characters that were split up in multiple different parts, and they were all controlled by code. And you had like some simple animations where your character would like jump and squash and do backflips and kick someone in the face or something like that. But I was never really a good artist, so it always looked like crap, but whatever. So, what I'm gonna do now is I'm gonna show how I did that. And we're gonna sort of like remake the game in Unity. So, let's go back to... Nope. Where is it? Yes. Yes. Yes, whatever. So I prepared some graphics already, so we don't really have to sit through a painless process of making a crappy looking level. And yeah, this is the level. It looks like this. I drew it myself. I'm the master drawer guy. I'm totally not an artist, never mind. And it looks kind of like this. Yeah, that's about it. So that little thing there is actually our character. And we're gonna make it move with animations and stuff. So we have some little graphics here from the old version of like a mouth that's opening and like some weird things or something. So we're gonna just drag them in here and see what happens. So with this, for example, we probably want to like maybe move these rotation pivot points around so the thing rotates correctly or whatever. And yeah, I sound really uninteresting, don't I? I know. Come on. Yeah, like that. Yes, apply. So let's move this thing over here. Let's move this thing over here. And let's make a little hierarchy here. We're gonna have this little tail piece under here. And it's gonna be here. Like that. And we probably need to make some order for some drawing order here so the tail doesn't appear in front of the body. So for example, this would be -1, this would be -2, and yeah, that's about it. You can like rotate this thing or whatever, rotate this thing. Now in GameMaker, when I was making this game, I could just draw, I could write like one line of code and it would actually draw a sprite, but here we actually have to move around objects, so it's going to be a little bit easier in that regard. And then we can probably put in some like paws or whatever, some feet. So like, oh no, this thing is like off center. And this should be like front left, maybe another one front right. This is gonna be rear left. Like that. And right one should probably be in front and the left one should be in the background. And it should look something like that. Or something. And then we could add some mouth to the mix as well. Something like that. There's some eye holes as well, but they look really low res, so we're just gonna make little procedural sprite instead. I'm gonna make a, come on, sprite circle. Yeah, let's just call it circle. Okay. And let's move it to here. And that's a and I probably want some pupils as well. So let's just copy these. Let's move them as child objects and pupil left, pupil right. Let's make the color black. Ooh, that's creepy. Something like that should be good enough, I think. Now he's completely white. Not to be racist or anything, but we kind of don't want that because it's just weird. But we're gonna fix that a little bit later. What we're gonna do instead is we're gonna make a little. We actually already have like a little script here called rodent, and since this is about procedural animation, we're probably just gonna stay at coding process a lot. So let's make what the hell? So let's write some code for the rodent. It's gonna be a child class of the character, and we could write some public variables for things like transform pupils, and this is gonna be an array containing just two elements, and then we might actually do some sprite renderers. No, just sprite renderer. And this is also going to be an array. Body parts. Okay. Colored body parts. And I'm going to make a new variable called public color for color. And let's make it colored. Whatever. Now it's gonna be just black by default. Oh no, wait, it's gonna be black by default. We don't want black. Yep. And just to show some stuff in the editor already before, without running the game, let's do execute in public in edit mode. And from there on, we're gonna do some other things to do whatever. Anyway, so we're gonna do a for each loop for color body parts, and for here we're gonna, for each of those body parts, we're gonna change its color to fur color. So now, if we're going to add, for example, all of these things, tail piece 1 and body, if we're going to add these two color body parts, we can then change the color of the thing or whatever. So you can see that we actually can easily color a little guy. Let's make him brown or something. Yeah, no, yeah, yep, that's about right. Okay, so next step, let's run the game. Okay, So we could probably do some code here for tails, but instead let's try to do some physics instead. So let's make this tail a physics object, this tail as well. Let's add some physics to it. I'm going to use 3D physics instead of 2D ones because, well, why not? Actually, all of this scene uses 3D colliders. I like to use 3D colliders because I always like to add some 3D stuff to my games. So, just in case, I'm just using 3D stuff. So let's just add some box colliders to the tails. You don't really have to do that, but whatever. And let's make these boxes a little bit smaller. And also let's make them using a layer called, I don't know. I'm using this specific layer because why not? What? So, actually everything under here should be that. Actually, the reason why I'm using a different layer for these objects is because if they're containing a collider, you probably don't want them to collide with the environment. At least not a lot. So we probably don't want the body parts to collide with body parts, and we probably don't want the characters to collide with the body parts. So character it is, a new layer for the rodent guy, and we're gonna go to the physics settings, and we're gonna disable body parts and character collisions here. So now if you run the game, it should be kind of okay. What? Oh, the tail collides with the wall. Okay, we should probably disable everything regarding body parts here. No collisions for body parts. Oh, that's even worse. That's because the tail has a weight. So let's give it some rigid body stuff. The body should also have a rigid body, because why not? And also a collider, box collider. And this is going to be a kinematic rigid body because we don't want it to use like actual physics. We don't want it to fall down because we already have that. So here we're gonna use, actually, you know what, if we run the game now, something horrible happens. Yeah. For tails? No. I have a plan, master plan. So for each tail, we're gonna be using actually, know what? Let's make it use interpolation. Yes, exactly. Let's use character joints because why not? And we want these axes to use the z-axis because so many questions. No, actually, no, you're not asking any questions to me. So whatever, I guess. The anchor should be right there and right there. Say what? Character joint? I have no idea. It's like probably from 2004 when the first version of Unity was made. Actually, I actually have no idea. It was there ever since I started using Unity a couple years ago. Okay, so we probably want the tail 2 to be connected to tail 1 and the tail 1 to be connected to the body. And now, behold, physics that don't work. Let's not use interpolation because that, oh my god. Yay! Works. That was way better than expected. So let's I have no idea what these mean. Like height twist. What? What is this? Swing. Okay, so let's try to put everything to 90 degrees. Doesn't always work like that. But just to be sure, we're gonna go to the constraints. We're just gonna freeze the z position and the x and y rotation. So you can't really rotate like inwards or outwards of the screen. So yeah, that because I just like to use 3D stuff instead, and because I may want to add like a block that would like rotate and use like 3D graphics or something real fancy. Because now, for example, I can actually make something like, for example, I could make a cube and then put the cube to 0 positions or whatever, and then make the cube smaller, put it over here, and maybe like rotate it like this. Maybe I want that to be in the game, and actually use 3D. But wait, no. No, because actually that wouldn't be even a good idea because you would have 2 physics engines running at the same time, and that's kind of crazy. So, okay, that didn't work well. Something like this, maybe? Yep. And we also would probably want this to... Oh wait, I don't have a render sorter scripts here. Well, anyway, the point is, I may want to have 3D objects, and you can see that I can easily use some box colliders to help me out with that. Now, the rodent itself has render sorting designed for this level, so I can have like it falling through this hole here and getting licked by the shadows. Licked by the shadows, what? So yeah, we can actually now see that guy fall down or something. And we probably want its body to be a bit heavier than the tails. Actually, we want the tails to be like not heavy at all, so we're just gonna use the lowest possible weight, mass, and we probably want some angular drag because why not? So yeah. Now we probably would want this guy to move around, and to do that, first of all, we probably would want to freeze rotation completely, so it would look like kind of like this. Now the tails are kind of lameish. Okay, you know what? Let's just make it so that the tail pieces could actually collide with the world, but no, wait. But they don't actually collide with the characters. We probably wouldn't want the character to collide with its own body parts. That would be crazy. So let's go to physics and let's enable body parts with the default layer, which is the world. And now the tail is, yeah. And yeah, that kind of works, I guess. Okay, so let's do something more with the character here. Let's make a private variable called private rigid body character variable called body. Let's make a wake function, and let's make body is get components rigid body. And now we probably would want to make it so that body dot velocity is velocity. Oh wait, we don't have a variable like that yet. Let's make another private variable called vector3 velocity, and velocity dot y is body dot velocity dot y, and we want to override its velocity to velocity. Yeah. Basically, I did this so that we would keep the y velocity of our character, so he could still use gravity and jump around and whatnot. But we can change its x value to use. Actually, no. Let's add some input that get access. This is horrible, by the way. Never do this at home using these default horizontal and vertical variable thingies is horrible. Just don't. Just no. And let's multiply it by time.delta time, because we're under update. It would be nice to use some delta time here. So what? Yeah, actually, you know what? Let's just make that a public variable. And let's press play. Woo! Oops. And yeah, we can totally. Oh. That. Yep. Okay. Yep. Maybe let's not do exactly that. Maybe let's just make it so that if we press left or right, or speed actually is like constant, because we would still have some physics attached to it. Oh my god, that's awful. Its tail like detaching or something. Let's make the max speed smaller. Let's say 2. 52. So eyes. Okay, so here we will call a function called procedural shenanigans, and we probably would want to make a function like that so it actually exists. And let's go for each for item eyes, and let's make a little enumerator that would tell us which direction we're facing. So so do we like left or right? Actually, right or left, because we probably want right to be the default one. And let's also make Unity has this really cool thing called attributes, and you could like write header. You could write in like graphics crap. You could duplicate this and like move it down, or like share stuff. I don't know. And here we would do public facing direction. And here we would do if facing direction is facing dir.left, then we would go, actually if it's right, we would change the position of the eyes, basically. So we need to get the original position of the eyes, I think. No. Yeah, I know. Just trying to figure out the nicest way to do it. But anyway, item dots local position is new vector 3. If we're gonna do something nicer, I'm gonna change this. But anyway, so we have like eye left. Its local position is 0. And eye right should be like 0.1, 0.50, no. totally right. No. Yeah. 12. So local position. Hmm. You know what? Instead of for each, let's do a for loop instead. So int I 0. I'll probably just fill and I. Wait, what am I doing? Wait, what? Oh, okay. So eyes, this thing is that. Um, this is really like shitcode. Don't do this. You know what? Screw this. I'm just gonna, you know, just no, just move around the eyes so it looks like you're turning. Eye left, eye right. This should be way better. Okay, so eye left is gonna be 0. Yeah, that transform. No. Ugh. Local position is new. Vector 3 and 0, 0, 0. No, wait. That's not right. Need some positioning as well. 0.4 should be about right. F and I right should be like this value. And if not, then well, we could just duplicate this and move it here. And we can just invert this. So this would be like 0, and this would be minus something. Nope, I want to do it with eyes. The pupils are going to be separate. This is so that I don't actually have to like flip the body. I could probably do this, but nope, not gonna do that. And now we probably want to make it so that if we get access, you know what? Let's just make a little flow for that. Float input 4 is this, and if this is like smaller than 0, then or something. Facing direction is placed at that left, and else this is going to be right. That should be. Oh no! Okay, so now doesn't work. Oh wait, it didn't assign the eyes. So this should be left. This should be right. So you can actually see the eyes already assigned a little bit. Okay. So let's make face, and let's put the mouth inside the face. Let's make another transform called face. In this face, we will actually flip around. So face dot local scale is new vector 3, and it should be -1. Oh wait, what is it? I'm not assigning things like that. See, something's happening. Oops. Okay, so now we may want to we're gonna flip this one as well, like that. And we're gonna do that by making another little thing called tail parent. And again, you know what, actually, wait, why am I doing this twice? That's all. I'm horrible today, as always. So we're gonna just face value. It's gonna be 1. Face that. No, just basically we can just use the same value for like face value. Same with this, and we can just take the face value and make it -2. It's -1. Is 1. Wait, what? Oh. And again, I didn't assign. What's wrong with me? What? Okay. Okay. You know what? Let's leave that for later. Okay. So we would want to have probably want to have another little section for feet. And here we're going to move this down. And this is going to be like foot rear left, foot rear right. Now I could probably use an array for this, but whatever. Front left and front right. So here we could. I'm gonna finally assign things first. Front left, front rear right, front right. There. So we want. Oh, what am I doing? I'd probably use an array for this anyway. God damn it. Yeah, let's use an array for that. So for each, no, it should be a for loop. Feet dot length. Actually, just use 4 because there's 4 of them. Foot dot weight of 3. New position is this particular feet. That position, and we're gonna take this particular foot and assign its new position. So new pos dot y should be like let's say time dot time. No, wait, no. Actually, let's make a little private section here for animation. So we want private float, feet rotation, feet time, and we want this time to be we want it to grow by some value. So in this case, it will be like math function that abs. Abs means positive. No, actually, no, we don't want positive. We can totally use like vector. No. Velocity dot x and multiplied by time dot build time. And let's move the feet up by math function clamp. No, wait. Max 0, and this should be like math function sin feet time, and this will be the height of the feet. Like how high do we move it? We probably want it to be like not really that high, and this will be multiplied by the I value. Actually, 1 plus y, because we don't want it to be 0. Oh wait, no. Plus I multiplied by like 90. What is this? What is this unexpected thing? What do you want? What do you want from me? There. So in the feet, we probably want to, I'll add all the feet. And we can put these here. And they disappeared. Okay, fair enough. Whoa. Oh, local position. Ah. And we would want to move them down by minus something something. Oh wait. Local position. There we go. Now we can enable this. And now if we move around, something happens, something horrible, something like this. Whoa, what the hell? We're gonna zoom in the camera a little bit. Yeah. By the way, guys, I know this is really rude, but I think I have to go for like 1 minute. Sorry. Bye. Sorry about that. Okay, so okay then. Actually, you know what? While we're at it, we're just gonna make a quick little script called game camera. Let's make a little following camera here. We can easily do this by making a private, oops, not partial, private variable called position, and we want this position to be like assigned to the camera's transform. So we would like void late update. Let's use late update because why not? And transform that position is position, and we can do something with the position value under update. And we want a public transform target, so we know what to follow. And position is vector3.lerp position target position. Let's do like 10 times $10. This will basically move the camera closer to the target by dividing the distance between the target and the camera. This will create like a smooth movement. And we want the position dot z to be like -10 or something, because we want the camera to be like away from things. So yeah, sure, but it's not that important right now. Now we can just move. Oh wait, wait, it didn't. What? Why didn't it update? Oh, it didn't save. What? Oh, Visual Studio. Bastard. So, move this to here, and now we can actually follow the player like that. Okay, so we probably want the height of the feet to be less, so 0.75 or something. And we probably want to do something else with the feet actually. So we'll have actually two. Well, we're gonna have 2 feet arrays, but we could just have one. But this is gonna be a little bit easier. So for this one, we're not gonna even multiply it by y or whatever. Feet left, and I'm gonna make a new value called float feet time. No, wait, we actually have a value later. Feet drop. Nah, height. What am I doing? I don't even need to do that. So this is going to be plus left. And this is going to be new point. So right. And this is going to be like plus 180, because we want one set of the feet to move at the same time, and there are other moving like after that. So it will look something along the lines of, actually, you know what? Also, we probably want this only to happen in like if application is playing something like that, because we don't want these errors to happen while we're in the editor. It's a little bit annoying. So we're gonna have front, left, and front, left, and rear, right. Let's just do it on this, and then these two. So it looks something like this. Actually, no, that doesn't look that good. Let's do something else instead. Let's actually do like left and right. How will this look? A little bit better, I guess. But we want these feet to move forwards and backwards as well. So we would want these feet to have some kind of a oh my god, this is so difficult. See, this is why you have to actually learn to make animations by using things like animators, because procedural animations sometimes are really a pain to make. You know what, let's actually do something else for a change instead. Yeah, we could do pupils. To do pupils, we can do a bunch of different things. We can actually make a value called something like public vector 2 pupil target. Actually, should be vector 2. And the pupil target will basically be basically a direction in which the pupils will look. So you can do a for each pupils and pupils. Oh yeah, local position. Actually, it should be just position, because sometimes local position doesn't really work well with if you're rotating things or scaling stuff. Item dot parent dot position plus this should be like ice target. Now this isn't like target in the role space, this is like just a direction. So this would be a new vector 3. And we want to normalize it and multiply it by a value that would be approximately 0.6. Wait, what? What? Oh, that's right. Yeah, we want 0.3 or something. That was weird. I mean, that wasn't weird. That was weird. And multiply by 0.3. And now if we run the game, oh yeah, we should assign as well. Let's send pupils here. Three. Nope. Okay, so we can actually like move around the eyes, and this works for some reason. Oh yeah, I know why, because that was like the local position. I mean, we're actually moving the pupils in wall space. So let's try to move them. Like that. Yep, that's about right. Actually see that we can make the character like look in various different directions, and we can totally make it so that pupil target could be like pupil target text would be. Oh, actually, this would be like new vector 2, and this would be velocity dot x and velocity dot y, and yeah, we can now make the pupils look in the direction you're going. We probably okay. Let's return to the tail. We want to maybe we can like not use the body for this. We could use the tail parent instead. So let's make it a static rigid body. Let's make the tail attached to the tail parent. And let's make it so that the tail parent actually scales. I really hope this works. No, it doesn't. Okay, actually, there's a different way to do it. We can, instead of using local scale, we could maybe do something else like rotation. Is a quaternion dot Euler, and it's gonna be 0. It's gonna be 180. So, and face value can be minus 1, 0. So this should be like 1 plus face value divided by 2 multiplied by 180. I don't know. Basically, I'm just trying to use the same face value to rotate the tail parent object by 180 degrees. But by default, it's like 0 rotation. So let's try to not maximize on play, and let's see if this works. Nope, it doesn't work at all. Oh, wait, maybe 90? I broke it. Oh, we're getting somewhere. You know what? Just tail rod. No. Oh my God! Visual Studio. Should be 180, and let's just use this value here. Oh, look at that! It works. Okay. So these pupils are like these eyes are like everything here looks really rigid. I mean, like the whole like rotation or whatever. Let's fix that. Let's make it so that yes, that was my neck. Let's make it so that these things are a little bit smoother. So let's use something called, I know what, let's just use floats. No, let's not use floats. What is this? Vector 3, left eye position, right eye position. And we would want to duplicate all of this. And it should be like vector 3 lerp and I write dot local rotation, local position, and like multiplied by 10 dot out times all the time. And we can do the same thing for the other eye. This is a really dirty code, by the way. I'm not trying to be like to write nice looking code right now. So you're gonna see that the eyes are a little bit smoother now. We could do the same for pupils. But let's just make it so that by default the pupil target just moves vector 2 dot lerp pupil targets that and by time delta time. Yeah. So now if we try to move in some direction, it doesn't work at all. Oh. Maybe this works. Oops. Wait, what? Okay, I think I'm dumb. Oh, wait a second. Ah, I see. Actually, don't. I'm lying to you guys. Really? Okay, that's another problem that we should probably fix. Let's zoom out a little bit. Now the thing is, if we move into walls, we stop. And the reason why we stop is because our character has the default physics material. Now what we should do instead is we should make a new material called where is it? Physics material called character. And let's make it so that friction is completely 0. Should be, we don't know, it should be maximum. God. Yeah, it should be minimal. And now if we walk into walls, we should probably slide down. Yep. So, oh wait a second. Oh. Okay, so we probably want this character to jump in some way. So we should make a new physics variable called grounded. And we could check this variable by shooting some raycasts downwards. So we can do that by, we're gonna shoot just one raycast. We can do multiple raycasts as well, but I think I'm talking too much. Just gonna try to wrap this up. So raycast, and we're gonna do it from transform that position. Direction should be minus vector 3 dot up, which is downwards, and then we should probably what? Raycasting position? You don't need array. You'd need a distance, which would be like, well, you can use array, but you can use separate variables as well. And this thing is like, let's say 0.3. That will be the distance of the raycast. And if that happens, then the grounded is true. Actually, no, let's just say land. And let's make a function called land. Grounded, then grounded is true, and we're going to do some other things here a bit later. And then yeah, and if the raycast doesn't hit anything, then we're not actually on the ground. No, not necessarily. If the raycast goes outside of the box, you don't actually hit yourself. With a yeah, but okay, fine. I don't know what if I okay, let's do public layer mask ground layer. Does that work? Yeah, it does. Okay, so let's do char controls. And here we're gonna do something like okay, whatever, I'm not gonna touch that. Here if we're gonna press input.get key down. I'm gonna use keys here because why not? And let's do space. Okay. No, actually, let's make a new function for the quick make jump. If not grounded, then return. We don't want to jump, we are not grounded. And then body dot velocity is 5. It's just a random number for jumping. What is this? Oh wait. Right. Doesn't seem to work. Why is that? Oops. You guys want to take a break? Or what? Well, just a couple things really. But anyway, actually, maybe I can just wrap it up in a second. Uh, let's just make velocity. Oh, actually, no. Oh yeah. Oh yeah, right. That must be it. Yeah, it should be default. Yep, that works. Okay, so we want the feed stuff to actually just only happen if we're grounded. And let's make a quick little something to finish things up. Let's make a variable called private float squash. Basically, the squash is going to squash the body, basically. And this object is going to be like under here or something. And no, actually, no, let's move lower. And everything is going to be under that parent. And let's just make a new transform for that. Now the thing is, we want it to kind of like squash downwards and then like expand on sideways. So let's do like dots local scale is new vector 3. And it should be like 1 plus squash. Yeah, and then we want it to like squash downwards. Like so. Actually, let's make a new variable called smash squash smooth. The squash smooth is going to be basically another version of the squash. We could probably use something way better than this, but should be fine for now, yeah. So squash and like 5 dot time dot delta time. And yeah, let's oh, and also squash should go to 0 gradually. So if we jump, by default we would want to, if we are not grounded, then squash should be like minus vector, I mean body dot velocity dot y. Oh, and also let's limit squash to, let's clamp it to minus 0.75 or something. 0.75. So if we jump, we're gonna like squash like vertically, and if we land, we want to squash a lot. Actually, no. No, just Just splash. Let's not do any like velocity tests or anything. Oh my god! Forgot to do this. And whoa, what? Oh, it's reverted. Well, actually, I guess we can almost finish or something. Yeah, let's make a break, I guess. Yeah. Thanks. It was fun. Legend. Ah. Что sana. Esse cara é legal, parece animado isso depois.
Can I?
Mas bem, isso não vai estar. Yeah.
Let's start Mark.
House.
Yeah, give me your number. See if they Oh my god, she likes
Can I have sandwich?